All right, hi, I'm Malynda Chizek Frouard, and I want to talk to you about a very simple experiment that I ran in 2017 during the total solar eclipse that crossed the United States using this. All right, so there is just a fun picture of that particular solar eclipse because I can. I did not take that picture. And a map of the total solar eclipse to explain why seeing totality in a solar eclipse is so special. The path of totality is a very narrow strip, so you have to be in a good place at a good time to be able to see a total solar eclipse. And so my husband and I and millions of other people in the United States took a special trip to find where they thought they were going to see the best experience of the solar eclipse. So this one was in August, and there tends to be cloudier weather in August in this part of the United States. I happen to live in DC, and my husband and I flew out to Colorado, and then we drove up to Glendo, Wyoming to watch this eclipse. So the motivation for this experiment, I work as a software engineer by trade, but by education, I am an astronomer, and light levels are of course very important to astronomers. And so determining light levels during sunrise and sunset and events such as solar eclipses are actually very complicated because of atmospheric refraction. It's very much dependent on the cloud levels or the amount of water in the atmosphere or the amount of dust. And just to give you an idea of how much light, our eyes work on a logarithmic scale in sensitivity to light. So on a night with a full moon, it's approximately 1 lux in illuminance. If you're standing outside in direct sunlight, it can be up to 100,000 lux. So the equipment I used, I've got right here, is a Raspberry Pi 0W and also a Pi Moroni Enviro hat. So the whole setup cost me probably $35, and I hooked it up to a USB battery and ran that. Here I've got a picture of one of my test setups just from inside my office, set it on the windowsill and took a look at what sort of lighting I got from indoors. It turns out it's very different from outdoors. So on Eclipse Day, my husband and I woke up at midnight and drove for 3 hours or so to get to Glendo, Wyoming. It's a town of about 200 people, and they were expecting to host about 20,000 people. What I'd heard was that in fact, they ended up getting something more like 90,000 people showing up. Anyway, so we ended up in this giant parking lot created just for this event. And my husband and I and my uncle and cousins all walked up to the top of this hill right here and spent our day enjoying the view. So here I have a picture of my Raspberry Pi sitting out in the open. There weren't too many people around, so I wasn't in risk of having anybody coming and standing over the Raspberry Pi and ruining my illuminance experiments. And we also got to have a nice view of a beautiful lake out there. So some of the results from my Raspberry Pi, it gets the sensor has RGB color as well as an illuminance sensor, and also it's got a temperature sensor on board. So for RGB color, I was just curious to find out what happens to the color of the sky during an eclipse. And it turns out that during a total eclipse, the sky actually appears bluer, which I thought was interesting. I didn't actually look too much into that because that was not my primary objective, but I thought that was pretty darn neat. Some of the data that I was more interested in, the temperature drop during an eclipse. I'd heard that temperature could drop like 20 degrees or more, and I just couldn't fathom that. One problem with this particular sensor is that the temperature sensor happens to sit more or less right directly over the CPU. So these temperatures are approximate, not exact. So with the illuminance sensor, I learned from my experiments indoors that it covered indoor illuminance pretty well. It turns out that when you go outdoors and it's in direct sunlight, we actually maxed out on what the sensor was capable of looking at. And of course, during the totality of the eclipse, we bottomed out on what the sensor was capable of. So for future experiments, I plan on getting a light sensor with a bit better dynamic range. And Pimoroni has updated the EnviroHat to place the temperature sensor somewhere else other than directly over the CPU. And of course, what else could I possibly want but to make more of these and have them scattered throughout the path of the eclipse track. The next solar eclipse that's going to be visible in the United States is an annular eclipse on October 14th, 2023. And the next total solar eclipse is going to be in April 8th of 2024. And here is just a fun map that is showing all of the total solar eclipse tracks for the 21st century. Anyway, so that is my talk.